Hi, this is Dan Bullard, retired electronics engineer, sitting on the front deck of my house, but again, it's a fun day at the marina. We had a neighbor, his dog jumped in off of the boat, or fell in off the boat, and he went in after him. And guess what? Nobody's seen either the dog or the owner the whole night, so the sheriff's got divers here. It's crazy. Here's a little advice for you. If you have a boat and you have a dog, kill one or the other. You shouldn't have two. Don't do both. Okay, so in the last video I talked about that really cool method that I came up with 20 years ago for testing filters. And it's kind of cool because Tin Lamb showed me how to measure, well, he showed me parts of how to measure a filter's roll-off by making three measurements. And so you measure a low frequency and then two higher frequencies. And I don't know how he did it, but from the slope, because you know in a low pass filter, the slope is linear more or less. So you can figure out where the roll-off is on the filter. And so it was a really cool technique, and it was really fast. And I showed you how the FFT was, it's like 1.5, 2 milliseconds for a 2048 point FFT. 2048 point FFT in 2 milliseconds, a millisecond and a half, something like that. And that was 20 years ago. With multiple cores, it's probably just screaming. But I made a point there and showed you these three waveforms, the 1 megahertz, the 15 megahertz, and the 20 megahertz. And I showed you that the peaks are all exactly the same. Now you might look at the 20 megahertz and say, oh, well, that's got some artifacting thing going on. No. That's what a guy with a master's degree at Maxim would tell you. That's not it. That's not what's going on. There's no artifact crap going on there. That waveform looks different because it's a different frequency and it displays differently. You can't look at the way a waveform displays. That's why scopes are so unreliable, really unreliable. You really shouldn't use a scope. I mean, I do use scopes occasionally, or I have used them in the past, but really the trick, the important thing is to use frequency domain. In that picture, I showed you that each of those three frequencies was exactly the same amplitude after I calibrated. And I prove it by showing you each of the amplitudes to within microvolts of each other. I mean, maybe 50 microvolts apart in 1 volt peak amplitude wave. So that's pretty incredible. So, but you might wonder, well, wait a minute, just because the peaks are the same doesn't mean that the amplitude's the same. Oh, really? Now, I did that video for you on CMRR, CMRR test on an op amp done by Raytheon. I have a Raymarine radar, and it's done by the same people. But I worked with the Raytheon guys. They are fucking idiots. They are complete fucking idiots. And so, in the CMRR test, they were measuring the output of this op amp, and so they put in a relatively high value, and they got a relatively high value out, and then they put it in to both inputs, and you get a very small signal out. And so what they were doing is they were capturing, I think it was 1,000 samples for 1 cycle of the wave. 1,000 cycles, and it was a 10 kilohertz wave. So 1,000 cycles. Now, they got terrible numbers because look at the wave. It's just noisy as hell. So they couldn't use that. So they tried, the smart guy would go off and do an FFT, but these guys are not smart guys. The Raytheon people, they're not very smart guys. This is for an F-16, by the way. So, FBI, I guess you can come and arrest me now, They were doing 1,000 samples and they couldn't get decent results. So what they then did is they took 2,000 samples. They took the first 1,000 and the second 1,000, and they took the average. So sample 1, average sample 1, sample 2, average sample 2, sample 3 average with sample 3, and so on. And so that's like flipping a coin multiple times, right? You're going to average it out, and you'll find out that it's about 50%. What do you get? Heads or tails? 50%. Well, taking 2,000 samples and averaging out didn't get rid of the problem either. So then they went 4,000 and 8,000 and 10,000 and 20,000 and 40,000, and they went all the way up to 4 million samples. And they finally got decent numbers. CPK is what their thing was. They had to get over a certain value in CPK. And you can look that up. I'm not going to try to explain it. But they were getting terrible numbers, and they didn't use an FFT. Now, when I did it, I used an FFT, and here's my wave compared to their wave. This is their wave, this is my wave. So, why did I get such a beautiful wave? Because I got rid of everything that wasn't 10 kilohertz. The test was about 10 kilohertz, nothing else. I didn't care about noise, I didn't care about anything else. I just wanted to look at the 10 kilohertz. So I did the FFT on it, threw away everything that wasn't in the 10 kilohertz bin 9, and then I did the inverse FFT, and there you go, there's the wave, 10 kilohertz. That's my 10 kilohertz wave. When you have a single tone, you can absolutely guarantee that the relationship between the peak and the RMS is 0.707. Guaranteed, absolutely. If it's a pure sine wave. But if it's not, if it's something else, there's no guarantees. There's no guarantees. But the guys at Raytheon didn't know that, or didn't. You know, they all had degrees. They all had degrees. So they took this nasty signal. They took 4 million samples, averaged the shit out of it, and they finally got some kind of a wave. I don't know what it looked like. And then they threw away the top and the bottom peaks for the most part, and then they took the peak times 0.707. So that's crazy, because there's noise in there, there's 60 hertz noise, there's all kinds of noise in there. You don't know where it's coming from, especially when it's a really, really tiny signal from the CMR test. So 0.707 times peak gives you the RMS for a single tone. And so I can prove that a million ways from Sunday. But don't worry, this is, you know, what Raytheon was doing was for an F-16. You know, they were probably much smarter when they were doing, nuclear missiles like the Trident missile and all kinds of other things, you know, space projects and all kinds of things. So, you know, that's what I understand what's going on. You know, if the U.S. military goes up against the Russian military, good luck with that. The Russians are just as inept, just as incompetent. And why is it that Elon Musk is the only guy flying spacecraft up to the ISS anymore? Because he can do it. He's using people in the private sector who know what they're doing. The people in the government and the government contractors, they don't have a clue, not a fucking clue. I want to show you what I was doing, what I was working on when I was working at Tektronix. This is a tester I was using at Tektronix. This is one of the testers. They had another one called a BTS, and I don't even have a picture of that. BTS, which stands for Basic Test System. Why would you, I mean, who's their marketing guy, right? Who would name their company Basic Test Systems? Come on, give me a break. But Teradyne, this is a Teradyne A585, and I use this on the cover of my book, The Reluctant Road Warrior. This was me in, well, it wasn't a secret environment, but it was, you know, you weren't supposed to be taking pictures and stuff, but I took a picture of me in front of this Teradyne A585, and that's where I did this test, and they did the test on the same tester. So the same tester, I got infinitely better results than they got using this exact same tester, because they're fucking idiots. And that's Raytheon. You know, they only make nuclear missiles. I mean, it's not like anything important is going to happen, you know. Jet fighters, nuclear missiles, you know. They made the Javelin missile. You know, I mean, stuff like that, you know, inconsequential. Nobody's going to get hurt by anything like that, you know. Not like the credit card that I did with the smart card. My credit cards have a smart card chip now, so 20 years after I worked on it, I can now wave my credit card over this thing, and hey, it works. Look at that. So that's the Raytheon people. They're just, I mean, the Chinese government is the same thing. They're complete fucking morons. This Teradyne 8585, that's a big system. The STS 5000, that's a big system. STS 3000, big system. These are not like little voltmeters or, you know, spectrum analyzers or scopes or signal generators. KISS analog. He's got this whole wall of garbage. Garbage, garbage, garbage. You know? I mean, just because you have a bunch of stuff that you put money into doesn't mean that it's good for anything, you know? I mean, signal generators, if you use a signal generator, I don't think I've ever used a signal generator in my whole life. I mean, scope, yeah, but I mean, scope's kind of for emergencies, you know? Back when I swear to God, this is true. Back when I was in the Navy, we were working on the radar PPIs, the radar repeaters, and we had to work on the radars, the SPS-10, and then we also had to work on later, kind of near the end of our course. It was a 9-month course. 9-month course. So the last part of the course, we had to work on the PPI, the planned position indicator, which is basically the radar scope. And that's what the scope dopes used to look at ships and other things that the radar was seeing. And it was really cool. But when I was in school, I swear, this is true, I would have people, Petty Officer Bullard, can you come here? And this is in a lab, you know, I'm in a lab. I'm not the instructor, I'm nobody, you know? And they're like, hey, can you help me like figure out this scope, get this scope working? Because they gave us things to probe on the PPI, on the, it was called a SPA 25, I think. They gave us things to probe, and you had to look for specific signals, and they wanted you to draw the signal. Well, they couldn't get their scopes to work, and so I was the guy. Everybody was calling me, Petty Officer Bullard, can you come look at this? Can you help me figure this out? And so I was the guy who helped them with their scopes. So even when I was in at Mare Island doing crypto, which I could tell you more, but then I have to kill you. We had a guy who pulled up some signal on his scope, and it was a real crazy looking sine wave. And he says, I thought this was all digital. And I looked at it, he had the volts per division turned down to like 2 millivolts per division. What are you doing on 2 millivolts per division? Click, 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 click. Finally, we got a square wave. So he was getting overshoot and undershoot on the square wave, and that was showing up as a sine wave. So you got to know what you're doing, you know. If you're a complete fucking idiot, nobody can help you. And this guy, KISS Analog, you know, I'm sure he's a nice guy, but he's got this wall full of equipment, spectrum analyzers and scopes and signal generators and stuff. No, no, no. That's not what you do. That's not, if you want to know electronics, you don't use that garbage. That's crap. You have to use something like an STS 5000 or a Teradyne 8585 or, you know, something like that. A Next Test Maverick Lightning, you know, something like that. You don't use spectrum analyzers. You don't use signal generators. That's stupid. You have to use coherent sampling. And if you want to understand electronics, you must do coherent sampling. You have to do it. You can't use signal generators and scopes and spectrum analyzers. That's stupid. And so I feel bad for the guy at KISS Analog. He's working to make his channel and everything, but if you do coherent sampling, you can get a decent signal. You can see exactly what's going on because you can do an FFT with coherent waves, and so the waves show up in a specific bin in the FFT. They don't show up as a smear. They show up in one bin. So that 10 kilohertz I was doing, that showed up in one bin. Every nanovolt of 10 kilohertz showed up in one bin. The bin next to it had nothing. The bin on the other side had nothing. But the bin with the 10 kilohertz, bin 9, that had every nanovolt, every picovolt of energy from the 10 kilohertz went in that bin. And with a spectrum analyzer, you cannot do that. You cannot do that. So, you know, I don't believe these people, you know, don't. You can watch them if you want, but I watch them for entertainment. Like, you know, I don't want to say they're stupid, but, you know, they're complete fucking idiots, you know. If you haven't used the Teradyne A585, notice that the guys at Raytheon used the Teradyne 585. They sold it electronics, and this picture was taken at Tektronix, and it wasn't supposed to be taken, but, you know. Funny thing about that thing, that Teradyne was a big machine. How big was it? How big was it? It was so big, I was stuck in there working on doing some testing some devices for F-16s or for Trident missiles or something. And I got a phone call. You're not supposed to have your phone on a test floor, but I had my phone with me and I just happened to get a phone call. And guess what it was? It was a recruiter. So I hid behind the Teradyne A585. It's a big machine. I hid behind the Teradyne and had a conversation with a headhunter. I wasn't supposed to do that because, you know, you're not supposed to have any electromagnetic radiation inside the test floor. But I was looking for another job. I didn't care if they lost a couple of parts, you know. I mean, how bad could it be, right? They're going to lose 10 parts in, you know, 10-minute test time. Who cares, you know? So I had a nice conversation with this person, and I ended up getting a job, not that job, but I ended up getting a job working for Applecos after I got let go from Tektronix. So the Tektronix guys were just as stupid as hell. They didn't have the first idea about what was going on with FFTs or any of that stuff. So, and Raytheon too, you know. Like I said, it's nothing to worry about. They only make nuclear missiles, you know, it doesn't matter. F-16s and Javelin missiles and nuclear weapons, space, I mean, come on. You know, none of that stuff matters. None of it matters to me, right? You know, I'm a big fan of SpaceX because that's a private sector company. They know what they're doing. If you fuck up, you get kicked out, right? You get thrown out, you get fired. That's the way it works. For government contractors, my dad was a government contractor. He was a crooked son of a bitch. And I think I told you this. My first car was a Dodge Dart. Why was it a Dodge Dart? My dad bought me a Dodge Dart because it had a slant 6 engine in it. And the slant 6 was what they used in all government cars. So he could get my car's engine parts repaired by his friends at work for free, or he would exchange it because he worked in the warehouse. He could give them rakes or hoes or, you know, rototillers or whatever he wanted, whatever they thought was justified. So the government and the government contractors are crooked as hell. We don't want anything to do with those guys, okay? So anyway, not the sheriff. The sheriff came by and I lost the video. Sorry about that. So I'm gonna let this guy go by, and I'll see you later. This is Dan Bullard from the